All right, so a quick recap of what we did yesterday. Uh, we discussed what exactly the hardware acceleration means. We also discussed what's the difference between the resource resizing and hardware acceleration. We also try to understand the network security designs or the network security architectures from the deployment point of view. So, and there was a case uh, when you can basically put the router behind the firewall and when you can put the firewall behind the edge router. We also discussed that you can have a dedicated DDoS module, uh, or if you don't have a dedicated DDoS module, you either need to have a contract with the ISP to have the DDoS protection, which they ideally uh, provide. And if you don't have a valid contract, then you can go ahead with a separate DDoS device, or if your firewall has the capability of acting as a DDoS, then you can sort of use that one as well. So I'll quickly share my screen. Just give me. Please confirm if you can see my screen.
Yes, it's visible.
Okay. So this is the lab that we actually wanted to do, and uh, what I'm thinking is that I will discuss a quick packet flow of this to basically give you the idea that how this particular NAT cloud actually plays a role and how I was able to access this FortiGate, and then how this traffic actually will leave from the FortiGate, then hit this particular NAT cloud first, and then from the NAT cloud, how it basically talks to my PC and then uses the virtual adapter of this PC only on which I have joined the call, and then leads to the internet. So there you go. So the first and foremost thing here is this is my PC. It's running Windows operating system, right? It's Windows 11, by the way. So at some point, what I thought was that, okay, I sort of need to go uh, get along with the labs and do the labs. There is one thing that I needed, and it's called VMware, right? And when I say that I actually wanted to do the labs, it means that I want to play with the routers, FortiGates. I want to play with the switches. Yeah. Uh, so I want to play with the Linux machines as well, right? And all those devices are basically inbuilt Linux systems, right? And my PC is Windows PC. So the core of operating system here for all those devices to which I want to play, just because they're the networking devices, they're Linux systems, and my PC is Windows. So this PC is never going to understand what this uh, particular node or particular device actually understands, right? And it's again the same thing that uh, the code that has been written for the Windows is not something that can be comprehended by the Linux systems, and vice versa. Whatever is basically what are the set of lines, the set of instructions, the code, the programs that actually run for the Linux operating system is something that won't be comprehended or understood by the Windows operating systems, right? So what I'm going to do is I sort of need a translator, and that's the reason I put the VMware here. I call it hypervisor, right? Hypervisor is basically uh, a software that helps you to translate the system calls from one OS to other OS, right? And the moment I do it, it also does what? It installs one of the adapters with it. So that adapter is called VMnet 8, by the way. It's a virtual adapter that gets installed with this particular VMware on this particular machine. I can quickly show that. So if I go to this PC, I go to command prompt, I do ncpa.cpl to get the idea of all the adapters on this machine. I could see there are a lot of adapters. One of them is Bluetooth, Ethernet, and Ethernet 2. Ethernet 3 tail scale is something that I'm using for different purpose. Uh, I could see there is this one, it's VMnet 8, and then Wi-Fi adapter as well. So this is a virtual adapter. It gets installed with the VMware itself. And when you have it installed, it's also assigned a subnet, right? And for me, the subnet for this is 192.168.85.0/24. How do I get that? I come here in the command prompt again, and then I I can quickly check it if I do IP config/all. This is the VMnet 8, right? It's a VMware virtual Ethernet adapter for VMnet 8. It has a MAC address for sure. And this is the subnet that it actually falls in, right? So it's there on my PC. And not just this, it gets NATed to the physical adapter of my PC. So VMnet 8 has subnet 192.168.85.0, and then my PC also has one physical adapter or any of the active adapters that is on this PC which is able to talk to the internet, right? This VMnet 8 can get translated into that particular IP address then later on. So it's VMnet and I have kept it on NAT. And why do I kept it on NAT? If I go to the VMware, is it already open? It should be. Okay, there you go. So if I go to, this is by the way the VMware, and this is my EVNG running here, right? If I go to edit and then go to virtual network editor, I could see that here I have VMnet 8 adapter, right? If I check the NAT settings, I could see this is a network, and this is a subnet mask. It's actually hitting each and everything, sending it down to 192.168.85.2. Right? I'll explain what that actually means. So coming back to the topology. So this is the VMware. It gets a virtual adapter installed with it. It gets the subnet. This subnet has a capability to get NATed and then talk to anything on internet, right? Now on the VMware itself, I have installed EVNG, right? And within the EVNG, EVNG itself is actually Linux. It's Ubuntu. That's one of the distributions of Linux, right? So EVNG has the routers, the firewalls, the switches, Linux machines, whatever. So all that stuff is actually going to run over here, right? And my PC is able to reach to this particular device, any device that actually lies within the EVNG because of this hypervisor that is lying in between. So this is actually helping you translate everything that comes from EVNG. Yeah, it's just translating it, making it compatible for the Windows operating system, so that the user who is actually sitting here and then watching at the or looking at the Windows or operating system, he can understand what exactly all those Linux devices are actually doing, right? So this is the complete translation how it happens. Now the whole point is within this event I have put this yeah, so within the whole event what I've done is I am putting this port 1 and then connecting it directly to the net. So if I try to check what this net here is, it is sort of giving internet to your lab, right? That's the whole point why I actually called it. If I try to edit this, it's management cloud 0, right? Now, why do I need management cloud 0 here and what is the purpose? So let me come back here. So this was my FortiGate. This is the port 1. It's connected to uh, management cloud 0, right? Now the point is this management cloud actually is a virtual switch, right? Which is bridged with the VMnet 8. And this management cloud says that anything who wants to go to the internet, right, will always has to give me the traffic. And for me, the default gateway is .2, right? So if FortiGate at some point says that I want to go to the internet, I want to talk to 0.0.0.0/0, my gateway would be .2. It's 192.168.85.2. So from the same subnet of VMnet 8, .2 would be the gateway on the left-hand side for everything that needs to go to the internet. And since I am basically part of the VMware, so VMware is staying here, right? And then to the VMware, it's my PC over here, right? So on top of the PC, you have VMware, and on top of the VMware, you have uh, event actually going on here. Let me check if I can change the color over here. Yeah, there you go. So this management cloud till here is your event, right? And with the help of management cloud, you are able to make a connection with the VMnet, but VMnet in itself is actually part of the VMware, and VMware is actually hosted on the PC, right? So anything that has to go to the internet will have to send traffic, hand it over to .2, right? And this .2 basically has sort of uh, a LAN link, right? It's a virtual link that has one of the IPs .2 on the left side, which is towards the EU side, or any of the nodes that you actually have running in the VMware, right? And on the right hand side, it is .1. So for PC to communicate with whatever is in this network, which is 192.168.85.2, right? For PC, it has to hand over the traffic to .1, and then this link will help you to connect with anything that is actually falling in the subnet. So this is the complete flow here, how we're going to uh, talk to anything that's actually here in this lab, right? Now, what happened when I am trying to access 192.168.85.182, right? I just told you last time that this whole lab was not running, right? We just bought all these nodes one by one, and then what I did was I double clicked on this FortiGate and tried to configure it, right? The username that we kept last time was admin, and we also said that first time when you're just trying to open the FortiGate, you're going to hit, uh, enter the username first, and then you don't put the password there, right? You just hit enter, then it's going to prompt you for putting a password out there. So you keep anything. I hope It was 123. Yeah, that's the correct one. So that's the one that we used last time. Now, if I check, that's the first command that we're actually going to use. I do diag IP address list. So this is going to show me the IP address of all the interfaces. I could see that there is one of the ports, it's port 1. It has an IP address of 192.168.85.136, right? And the other one is 10.30.30.1. The other one is 127. These are the default IP address schemes that have automatically been assigned. Now to the port 1, if I want to check the configuration on this one, what I'm going to do is I will do config system interface and then do edit port 1, because this interface is connecting to the cloud 0, which is the management cloud of this particular event G, right? Let me come back to the putty. So I'm here. I will do edit port 1, and then if I want to check what is the running configuration on this one, I do show. I could see that it says the configuration that is actually present on the port 1 for now is it's part of some VDOM, which is root. We're going to discuss what this basically means shortly. And it's on mode DHCP. The protocols that have been allowed on this particular interface, right? It's ping, HTTPS, SSH, HTTP, and FGFM. Ping means that you can ping it, you can ping this interface. HTTPS means that if you have an IP address over here and then you try to do HTTPS on that, you will be able to open the firewall, right? Likewise, SSH means that if you have an IP address on this port 1 and you try to SSH on that interface, you can open it. And similarly, HTTP means uh, if you have IP address to this particular port and you want to take HTTP, you can open the firewall on this particular IP address on port 80, which is the HTTP, right? And likewise, FGFM, we are going to discuss that, what FGFM means. Set type physical because it's a physical interface. And set SNMP index, it's one of the indexes that it has actually given it for the purpose of monitoring, right? It's basically used for, I mean, if you want to monitor this particular port using the SNMP, the index at that time that this particular port has is 1, right? So now the question is, what I'm going to do is I will use this IP address then here, and I'm going to paste this in my browser, right? I do HTTP and there you go. So it opens the firewall. Now, what happened in the background? Can anyone help me with that? What exactly would have, I mean, the processes that actually happened in the background? Anyone? Yeah. So let me try to explain that. Now, this is my PC over here. I'm using HTTP 192.168.85.130. Was it 130? 136, right? This PC actually has one of the adapters now because of the VMware, and that adapter is VMnet 8, right? Now, the moment I'm hitting using this particular IP address in my browser only, right? It's more like your PC actually is sitting in the same subnet because you have one of the adapters with this IP address only, with this subnet only, right? This VMnet comes with 192.168.85.0/24, right? So what is going to happen is it's going to look for the gateway that it actually has, right? Now, VMnet 8 itself has an IP address of .1, right? I can quickly show you that. So if I do CMD again, yeah, there you go. So this is the VMnet 8 over here. It has an IP address of 192.168.85.1. So it's as if my PC lies in the same subnet, right? And it also has one of the adapters. It has IP address of .1. It's trying to reach out to .136. So they lie in the same subnet now, right? And this .136 is running behind the VMware on EVNG. This is VMware, right? Now VMware is connected to your PC using the VMnet 8, right? And this EVNG is connected to your VMnet 8 using the MGMT Cloud 0, right? Which is bridged with the VMnet 8. So I was trying to look for 192.168.85.136 on my PC. It just redirected my request to the VMnet 8, and VMnet 8 is bridged with Management Cloud 0, right? And then in the EVNG, you have FortiGate over here running, who has an IP address of .136. This is the whole flow. Any questions till now? Are you guys able to get it? I mean,
Yes, bro.
it is. Yeah, please go ahead.
No, I don't have any question. I am getting it.
Okay. Anyone else? I mean, again, this is not part of your Fortinet, but if you get this at this point, you can do labs for anything, literally anything, be it Palo Alto, be it running the Linux machines in the EVNG. Because when you get the whole packet flow, what exactly is happening here within the EVE itself, how is it actually um, talking to your PC and utilizing your PC to go to the internet, right? Because my PC basically is able to go to the internet using the router that's over here. It's at my home. It's a Wi-Fi router providing connections, providing IP addresses to the Wi-Fi adapters that's actually running on this PC. So this whole flow is very important, and I mean it's actually going to give you the visibility that what exactly is happening in the background.